Inverses of functions. How can you tell if the inverse is actually a function? We can do that by the horizontal line test. Now this should sound familiar. We've had a vertical line test, and the vertical line test basically indicates if the function is if the relation is actually a function. So what we did before is we took a vertical line and we moved it from left to right, and we identified, does it cross that graph in exactly one point? Does each x have exactly one y? That answer is yes. So this would be considered a function from the vertical line test. Now, let's go to the horizontal line test. The horizontal line test basically is saying, is the inverse of the function a function itself? If the function passes the horizontal line test, then we know its inverse is a function. This passes it, this does not pass it, so this would not have an inverse that is a function. It would have an inverse, but the inverse would not be a function. Let's go ahead and figure these out. It says determine if the inverse is a function. In other words, if I graph that, I mean just a real rough graph, looks something like this, and looked at the horizontal line, you're going to see that it passes. So this answer is yes, it is a function. The inverse is a function. Then find the inverse. So I'm going to replace the f of x with a y. Then I'm going to exchange the y with the x and the x with the y. So that becomes this. And now I want to solve for my new y. So it's x minus 1 equals 2y cubed divided by 2 and taking the cubed root of both sides. Now, I know that this is going to be the inverse, so I can write it in inverse notation. That's what this is. This is saying it's not to the exponent of -1, it's saying this is an inverse function. And it looks like this. Consider this function, determine if it's an inverse. This graph looks like this because it's a square root function, just with moving it to the right 3, and it's a little bit steeper. So what I'm going to do is figure out does it pass the horizontal line test, and it does. So the inverse is a function. Now what is it? Again, I'm going to go through that algorithm and switch the x and the y. By switching the x and the y, you're creating the inverse. This is the inverse. I know the inverse is a function, so now I'm just going to go ahead and solve for that y. X over 2, squaring both sides, and this becomes x squared over 4 equals y minus 3. So y equals x squared over 4 plus 3. In other words, f inverse of x equals x squared over 4 plus 3. Now, one more type of problem is this one. And again, they're limiting the domain here, which means if I graph this, it would look like this, but it only has x is less than or equal to 0, which means it does pass the horizontal line test. So I have to keep this in mind when I go ahead and get its inverse. Y equals negative x squared, switching the x and the y, multiplying through by a negative taking the square root of both sides, plus or minus. Now, this is where I have to use some knowledge, and I understand that the domain of f of x is this, which means that the range of my inverse is the same thing, is greater than or equal to 0, which means that is less than or equal to 0, which means that my y's are negative. That tells me that my y has to be that negative now. So my f inverse of x is going to equal a negative square root of negative x. Why? Because all of my y's are now going to be negative when they come out. So that's y is less than or equal to 0. That's tricky. The last type of problem, verify that this and g of x are inverses of each other. You could just go through and figure out what the inverse of f inverse of f is, and you could find the inverse of g of x, and just make sure that this one is equal to this, and this one is equal